Hey guys, so this is part 2 of the spicy IGCSE mensuration questions. If you're someone who's been following the channel, you would know that I started the series of questions where we created a spice meter, where we shared the easy questions, which were the mild ones. Spicy ones are some in the middle, and the hot ones are going to be the more advanced ones, which will be posted in the coming days. So if you're new, you can start with the mild questions and progress based on your understanding. If you're someone who's well versed with the questions, you can directly start with the spicy ones or the hot ones once I upload this. So enjoy this series, and I hope you understand how to solve mensuration questions better after viewing these videos. So let's start with the questions. This question says that the diagram shows a solid cone and a solid hemisphere. The cone has a radius of 2.4 centimeters and slant height of 6.3 centimeters. The hemisphere has radius r centimeters, and the total surface area of the cone is equal to the total surface area of the hemisphere. Calculate the value of r, which is the radius of the hemisphere. So they've given us the formulas for the curved surface area of the cone, which is pi rl, and they've given us the curved surface area of the sphere, which is 4 pi r square. So for the total surface area of the cone, the formula we use is pi r square plus pi r l. Pi r square is the area of the base, which is a circular face, and pi r l is the curved surface area. So radius is 2.4, so pi times 2.4 squared plus pi times 2.4 times 6.3. The 65.59 centimeters square. Now the question says the total surface area of the cone is equal to the total surface area of the hemisphere. If you look at the hemisphere, this curved part is going to be 4 pi r squared divided by 2, which is 2 pi r squared. Why did we divide 4 pi r squared by 2? It's because it's a hemisphere, not a complete sphere. So since it's half of it, so 4 pi r squared gets divided by 2. Now for the circular face at the top, that's going to be pi r squared. So total surface area of hemisphere would be pi capital R square plus 2 pi capital R square. That's 3 pi R square. Now, as the question says, the total surface area of the cone is equal to the total surface area of the hemisphere, which means 65.59 is equal to 3 pi R square. 65.59 divided by 3 pi, and take the square root of that, and R equals to 2.64 centimeters. That's your answer. And in part B, it says that the diagram shows a solid cone with a radius 7.6 centimeters and height 16 centimeters. A cut is made parallel to the base of the cone and the top section is removed. The remaining solid has height 12 centimeters as shown in the diagram. Calculate the volume of the remaining solid. So if the top part is removed, we can see that the total height of the cone was 16. Now it's 12, which means this top part is 4 centimeters because 16 minus 12 is 4. So if you draw a cone separately over here, the cone has a height of 4 centimeters. Radius, we don't know what that is. So what we can do is that we can treat these two shapes as similar shapes because this small cone is enlarged to this cone. So we have the height of this cone, we have the height of this cone, we have the radius of the bigger cone, but we don't have the radius of the smaller cone. So using the concept of similar shapes, we can find the radius of the small cone. So 16 over 4 is the same as 7.6 over r, r being the radius of small cone. So 16 r equals to 7.6 times 4, and r equals to 7.6 times 4 divided by 16, which gives us 1.9 centimeters. So now that we have the radius of the small cone, we can use the volume formula to find the volume of this cone. So that's going to be 1/3 pi 1.9 square times the height, which is 4. That gives us 15.21 centimeter cube. So volume of the remaining solid is going to be the difference of the volume of the big cone and the small cone. Now, to find the difference, we need the volume of the big cone as well. That is 1/3 times pi times 7.6 square times 16. That's 967.77 centimeter cube. So you find the difference of these two. 967.77 minus 15.21. That gives 952.6 centimeter cube. That is the volume of the remaining solid. So remember, in these cases, when you're cutting a cone into different shapes, the top cone is similar to the entire cone. So using the concept of similar shapes, you can find the radius of the smaller cone, use that to find the volume, then find the volume of the larger cone, subtract the two, and that gives you the volume of the remaining solid. Next question says the diagram shows a sector OXY of a circle with center O and radius 9.5 centimeters. The sector angle is 53 degrees. A lies on OX, B lies on OY, and OA equals to OB. Show that the area of the sector is 41.7 centimeters square, correct to 1 decimal place. So to find the area of the sector, we do the angle divided by 360 times pi r square, which is 9.5. So when you plug this in the calculator, what you should get is 41.7 centimeters square, correct to 1 decimal place. Then it says the area of the triangle OAB is 1/3 of the area of the sector OXY. Calculate OA. So triangle is 1/3 of the sector OXY. So we already found the area of the sector OXY. That's 41.7. For the area of the triangle, we will use the formula 1/2 AB sine of angle O over here. So 41.7 divided by 3 is 13.9. In case you're wondering why did we use this formula for the area of the triangle, that's because we have a non-right angle triangle. It's not a right angle triangle. So we cannot use 1/2 times base into height because we don't have the height of this triangle, neither do we have the base. So it's ideal to go with this formula. And the condition for this formula is that you need two lengths and the angle between them. If you look at the question, they're asking us to find OA, which is one of the two lengths, and OA is equal to OB. So basically, A and B over here written are the same thing. And we have the angle, so we can easily find the length of OA because that's the only unknown in this equation. Everything else is given. So OA equals to OB, and we can say that it's X. So 1/2 times OA times OB times sine of 53 equals to 13.9, which is 1/2 X squared times 0.7986, which is sine 53. So X squared is going to be 13.9 times 2 divided by 0.7986, square root both sides, and X is equal to 5.90 centimeters. That is your length of OA, which is also the length of OB. Part B says the diagram shows a sector OPQ of a circle with center O and radius 24 centimeters. The sector angle is 60 degrees. The cone is made from the sector by joining OP to OQ. Calculate the volume of the cone. And they've given us the formula for the volume of the cone, which is 1/3 pi r square h. So if you remember, this is very similar to a question that has come in the past, I think in 2020. And you can easily find that question in the previous video for the spicy level questions. In that case, they also did the same thing. They had a sector and then they joined the sector to make a cone, and both the radius were joined. So pretty much similar to what we've done in the past. So this angle is 60 degrees. This is 24, which means your slant length is 24. To find the volume of the cone, we need the radius and we need the height. How do we figure that out? We know that this curved part, the arc length, is the same as the circumference of the circle. So we can easily find the arc length, PQ, which is going to be 60, which is the angle, divided by 360 times 2 pi r. R is 24. So PQ equals to 25.13 centimeters. As I said, the arc length is equal to the circumference of the base of the cone. So circumference is 2 pi r. So 25.13 equals to 2 pi r. 25.13 divided by 2 pi equals to the radius, which is 3.99 centimeters. Now, if we highlight the height and the radius, we can see that we have a right angle triangle. This is the height, this is the radius, which is 3.99. So using Pythagoras, we can easily find the height. So that's going to be 24 square equals to 8 square plus 3.99 squared. So 24 square minus 3.99 squared, square root, and that gives us the height, which is 23.66 centimeters. As you can see, we have the height, we have the radius, so volume would be 1/3 of pi times 3.99 squared times 23.66, and that gives us 394.4 centimeter cube. That is the volume of the cone. Question 10 says, the lengths of the sides of a triangle are 11.4 centimeters, 14.8 centimeters, 15.7 centimeters, all correct to one decimal place. Calculate the upper bound of the perimeter of the triangle. So this is also very similar to a question that you'll find in the previous video, where they asked us to find the perimeter of the given shape, which was a rectangle, I think. So as you can see, the pattern is very similar. They're repeating the questions, they're only changing values, they're only changing the shape. But the paper pattern is very similar to the questions that have come in the past. So if we draw a triangle, this is a triangle. This is 15.7, this is 14.8, and this is 11.4. All of them are correct to one decimal place. So one decimal place is our degree of accuracy for these lengths. And to find the upper bound or lower bound, we always divide the degree of accuracy by 2 first. So 0.1, because one decimal place, divided by 2, at 0.05. Now, since we're talking about the upper bound, and in perimeter, we're adding the lengths. So in addition, you find the upper bound of the measurements that we're talking about, and then we just put them in the formula. If they talk about the lower bound of the perimeter, you would find the lower bound of the lengths, and then you would put those in the formula to find the lower bound of the perimeter. So for upper bound, the first one would be 11.4 plus 0.05, which is 11.45. The next one would be 14.8 plus 0.05. That's 14.85. And then 15.7 plus 0.05, which is 15.75 centimeters. We have the upper bound of all the three lengths. So the perimeter would be the sum of these lengths, because perimeter is the entire boundary of the shape. So to find the entire boundary of the shape, we add up all the lengths. So that's going to give us 42.05 centimeters. That is the perimeter of the triangle. Then it says the diagram shows a circle with radius 15.6 centimeters. The angle of the minus sector is 150 degrees. Calculate the area of the minus sector. So minus sector is basically this. Minor means the smaller angle. So for this, they've already given us the angle. They have given us the radius. So you just directly put in the formula. 150 over 360 times pi times r square. So that gives us 318.5 centimeters square. That's your answer. Then part C is saying the diagram shows a circle, radius r centimeter, and minus sector angle x degrees. The perimeter of the major sector is 3 times the perimeter of the minus sector. Show that x equals to 90 minus 90 times pi minus 2 over pi. So perimeter of the major sector would be r plus r plus the arc length. So if this is x, this is 360 minus x. So arc length would be 360 minus x over x times 2 pi r. Simplify that, that's 2r plus 2 times 360. That's going to be 720 pi r minus 2 pi xr over x. This is the perimeter of the major sector. Now perimeter of the minus sector would be again r plus r, but now x over 360. Oh wait, that's 360. Let's divide by 360, not x. Okay, x over 360 times 2 pi r. So that's 2r plus 2 pi x r over 360. Now, if we create an equation out of these two, the major one is three times the minor one. Expand the bracket, so that's 6r plus 3 divided by 360 is 120. 2 divided by 120 is 60. So this is pi xr over 60. And this one simplifies to 2r plus 360 pi r minus pi xr over 180. I'm going to erase this part since I'm out of space. So I'm going to bring pi xr over 60 to the other side and take the 2r on the right-hand side. So 360 pi r minus pi xr over 180 minus pi xr over 60 equals to 6r minus 2r. Find the LCM of 180 and 60, that is 180. So we can multiply this fraction by 3 because 60 times 3 is 180. So 360 pi r minus pi xr minus 3 pi xr equals to 4r. So pi xr minus negative pi xr minus 3 pi xr is negative 4 pi xr. And we cross multiply 180 with 4r. I'm going to erase this as well. So that's going to be 360 pi r minus 4 pi xr equals to 180 times 4, and that is 720r. So all of the r's get cancelled out because each term has an r. 360 divide all of them by r, so it's 360 pi minus 4 pi x equals to 720. 360 pi minus 720 equals to 4 pi x. 360 pi minus 720 divided by 4 pi. Now if we simplify this, between 360 and 720, we have (360) common, so 360 pi minus 2 over 4 pi. 4 ones are 4, this is 90. So that's basically 90 times pi minus 2 over pi equals to x, which is basically what the question was asking us to show. Now, as you can see, I didn't have enough space over here because I was just rewriting in the same space given over here. But you would have the entire page and like you don't have to like erase the working and solve it again in different spaces. So it's quite lengthy, but like the steps are very basic and very small. Like the smallest error can change your answer very easily. But the best part is that you have the answer to the question. So if you do it wrong, like you did something wrong in the question. So you can just recheck your working and see where you went wrong. And this question says that the diagram shows the positions of a lighthouse L and two ships K and M. The bearing of L from K is 155 degrees and KL is equals to 112 kilometers. So if the bearing of L from K is 155, that means this is 155. Remember, bearing is always measured from the north of the point from which it says the bearing is from, and you measure it in the clockwise direction from north towards the line that connects both the points. Then it says the bearing of K from M is 10 degrees, so which means this is 10. An angle KML is given as 96. Find the bearing and distance of ship M from the lighthouse. So distance is this, and for bearing of ship M from the lighthouse would mean we draw the north at L and we find all of this angle. So to find all of this angle, we know that if this is 10, then over here, if we draw a line from over here, this part is also 10. Why is this also 10? Because in parallel lines, alternate angles are equal. The parallel lines over here are the two knots. As you can see, they're parallel. And this is the transversal, the line KM. So this angle over here, 10, is the same as this angle over here. Hence, this is 10. And to find this angle, we can easily do 180 minus 155, which is equal to 25 degrees. So this angle over here is 25. So total angle K, angle MKL would be 10 plus 25, and that's 35 degrees. As you can see, we have two angles on this triangle. We have angle K and angle M. So we can easily find angle L now. So MLK would be 180 minus 96 minus 35, and that's equal to 49 degrees. So this is 49. So if you remember the conditions of sine rule, in order for us to apply sine rule, we need one complete set of angle and length. And as you can see, we already have that over here. We have angle M and we have its corresponding length, which is 112. So since we already found angle K, so the corresponding length to angle K is ML, which I've written as X. So using sine rule, we can find the distance of ship M from the lighthouse. So that's going to be 112 over sine of 96 equals to X over sine of 35. So cross multiply 112 times sine 35 over sine 96. And that's going to give us 64.59 kilometers. That is the distance between ship M and the lighthouse. Now comes the bearing. So for the bearing, what we can do is that we need to find this angle over here. So once again, if you remember the rules for parallel lines, alternate angles are equal. So this angle above the line, this total angle here is 10 plus 96, which is 106. So if this is 106, this below is also 106 because they're both alternate angles, this and this. So that means for the bearing, we'll do 180, which is this blue angle, plus 106, and that gives us 286 degrees. That is your bearing. So 286 is the bearing and 64.59 is your distance. That's your answer. Question 1A says, calculate the volume of a solid cylinder with radius 6 centimeters and height 14 centimeters. So volume would be pi r square 6 square times h. That gives us 1583.36 centimeter cube. And it says a solid hemisphere with radius 6 centimeters. So for the volume, they've already given us the formula. All we have to do is substitute the values and solve it. So 4/3 times pi times 6 cube, and that is equal to 904.77 centimeter cube. Then it says the cylinder and the hemisphere and part A are joined to form a solid in the diagram. The solid is made of steel and 1 centimeter cube of steel has a mass of 7.85 grams. Show that 1 centimeter cube of steel has a mass of 0.0075 kilograms. So if 1 kilogram equals to 1,000 grams, when we reverse it and go from grams to kgs, 1 gram would equal to 1 over 1,000 kilograms, which means to convert the 7.85 grams into kilograms, we divide it by 1,000, and that's 0.00785 kilograms. Then it says calculate the total mass of the solid. So for the total mass, we need to find the total volume of the solid first, because 1 centimeter cube is equal to 0.00785 kg. So total volume would be volume of the cylinder, which was found to be 1583.36 plus, now it's half of a sphere, so that's a hemisphere. So which means we divide 904.77 by 2, and that's going to give us 2035.745 centimeter cube. So for the mass, we will times this by 0.00785, and that's going to be 15.9 kilograms. That is your answer. Question A says diagram shows triangle ABC in horizontal ground. AC is 15 meters, BC is 8 meters, and AB is 20 meters. BP and CQ are vertical poles of different heights. BP is 3 meters and CQ is 4 meters. AQ and PQ are straight wires. Show that angle ACB is 117.5 correct to 1 decimal place. So basically this angle. So as you can see the triangle ABC, we have all 3 lengths given. That means we can easily apply the cosine rule to find the angle. So it's going to be cos of angle C equals to 15 square plus 8 square minus 20 square divided by 2 times 15 times 8, which will give us negative 0.4625. And now we take cos inverse of that, and that's going to give us 117.5 degrees, which is exactly what the question was asking us to show. Then it says calculate the area of the triangle ABC. So to calculate the area of the triangle ABC, we need 2 lengths and the angle between them. And as you can see, we have 2 lengths, 15 and 8, and the angle between them, which is 117.5. So that's going to be area equals to 1 over 2 times 15 times 8 times sine of 117.5, which equals 53.2 meters square. That is your area of the triangle ABC. Then part C says calculate the length of AQ. To calculate the length of AQ is this diagonal over here. And we have this right angle triangle where we have the base, we have the height, so we can easily find the diagonal by using Pythagoras. So AQ square equals to 4 square plus 15 square. Hypotenuse square equals to the sum of the square of the other 2 lengths. So that's going to be 16 plus 225. And that's 241. Let's square root that. So AQ is 15.52 centimeters. Then it says calculate the angle of elevation of Q from P. Angle of elevation of Q from P. So that's basically, if we connect this over here, we have this right angle triangle. If this is 3, this is 3, and this is 1. And this is 8, because this length is the same. So we have the opposite, we have the adjacent. They want us to find this angle. Tan theta equals to opposite over adjacent. So theta would be tan inverse of 1 over 8. And that equals to 7.13 degrees. That is your angle. That is your angle of elevation of Q from P. Then part E says another straight wire connects A to the midpoint of PQ. Calculate the angle between this wire and the horizontal ground. So going from A to the midpoint of PQ, and they want us to calculate the angle between this wire and the horizontal ground. So this is another right angle triangle. And we need this angle. So as you can see, the question said that A is joined, A is basically joined by a wire at a point that is the midpoint of P and Q. So if it's the midpoint of P and Q, that means this length over here, this will be, when we draw again this line, we know that this part is 3. This top part now, since this was 1, so half of this is 0.5 and this is 0.5, which means this over here is 0.5. So this total length becomes 3.5. We call this M and we call this T. MT is 3 plus 0.5, which is 3.5 meters. Once again, we're using the midpoint concept over here, that A is joined to PQ at its midpoint. So that means this top part gets divided into 2 equal parts. So the 1 meter becomes 0.5 and 0.5, and 1 0.5 gets added to 3 to find the total length of MT. So that's 3.5. Now, to find the length of AT, we can see that this AC was 15, angle C was 117.5, and now this CT would be again half of 8, which is 4. So if we draw this triangle separately over here, what's happening now is ATC. This is 117.5. CT, I'm saying, is 4 meters. AC is 50 meters. The reason why CT is 4, because this triangle is in the middle of P and Q, which means this CB length, which is 8 meters, gets divided into 2 equal parts. Hence, CT becomes 4 and TB would also be 4. So as you can see in this triangle ACT, we have 2 lengths in the angle between them. So we can easily find the third length, which is AT, using cosine rule. E squared would be 15 squared plus 4 squared minus 2 times 15 times 4 times cos of 117.5. That equals to, that's 296.409. Now we take the square root of this value, and that gives us 17.21 meters. Now using 17.21 meters and the 3.5 meters, we can use this right angle triangle to find the angle. So we have the opposite, which is 3.5. We have the adjacent, which is 17.21. Let me just draw that triangle as well. So that's A, that is T, and that is M. MT is 3.5 meters, AT is 17.21 meters, and this is the angle that we're trying to find. So tan inverse of 3.5 divided by 17.21 equals to theta, and that gives us 11.5 degrees. That is your angle that this wire makes with the horizontal ground. Question 4 says a regular 12-sided polygon has side length 6 centimeters. Show that one interior angle of the polygon is 150 degrees. So one interior angle, the formula we use is n minus 2 times 180 over n, which is 12 because that is the number of sides, minus 2 times 180 over 12, and that gives us 150 degrees as shown in the question. Then it says the polygon is enclosed by a circle center O so that each vertex touches the circumference of the circle. Show that the radius AO of the circle is 11.6 centimeters correct to 1 decimal place. So it's a regular polygon. So that means all of these lengths are the same. And as you can see, we can make 12 identical triangles in this polygon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So which means if we divide 360, which is sum of angles at a point, by 12, 360 divided by 12, and that gives us 30. This angle is 30, and so is all of the other angles. They're all 30. Now, OA is the same as OB. Like I said, it's a regular polygon. So the distance from the center to the boundary is the same at each of the vertex. So it's an isosceles triangle. So X and X, let's say OA, which is equal to OB, is X. Since it's an isosceles triangle, we can easily find these two angles because they're going to be the same. So if we do 180 minus 30 divided by 2, that gives us 75 degrees. So this is angle OAB. So angle OAB is the same as angle OBA, which is 75 degrees. So we have all three angles now. We have one length. So if you remember the conditions for sine rule, we need one complete set of angle and length, which we already have. We have angle 30 and its corresponding length, which is 6 centimeters. So using sine rule, we can easily find OA. So 6 over sine 30 is the same as OA over sine of 75. So 6 times sine 75 over sine 30 is OA, and that equals to 11.59 centimeters. It can be rounded to 11.6 centimeters as the question wanted. So that's your answer. Then it says calculate the circumference of the circle. So for the circumference of the circle, we need the radius, and we just found the radius, which was 11.6. So circumference, which is 2 pi r, we do 2 pi times 11.6, and that equals to 72.8 centimeters. Then it says that the perimeter of the shaded minus segment formed by chord AB So to find the perimeter of the shaded sector, that's basically this part over here. So for that, we need the arc length AB, and we already have the length of the straight line AB, which is 6. So arc length would be 30 over 360. Why 30 over 360? But this was found to be 30 times 2 pi and r, which is 11.6. So when you solve that, what we get is 6.07 centimeters. So the perimeter is going to be 6.07 plus the 6 centimeters, and that's 12.07 centimeters. That's the perimeter of the shaded segment. Then it says that the regular 12-sided polygon is the cross section of a prism of length 2 centimeters. Calculate the volume of the prism. So since the polygon comprises of 12 identical triangles, so you find the area of one triangle, we can multiply that by 12 to get the area of the entire polygon. So area of one triangle would be 1 over 2 times 11.6 times 11.6 times sine of 30. That equals to 33.64 centimeters square. Then area of 12 triangles would be 33.64 times 12, which equals 403.68 centimeters square. So volume is basically a cross-section area times the length. Cross-section area is 403.68, length is 2, and that gives us 807.36 centimeter cube. That is the volume of the prism. Question 11 says a rectangular sheet of paper ABCD is made into an open cylinder with the edge AB meeting the edge DC. AD is 28 centimeters and AB is 20 centimeters. Show that the radius of the cylinder is 4.46 centimeters. Correct to 3 significant figures. So what we can do is, since the lengths are joining, B is joining C and A is joining D, so this length basically becomes your circumference of the circle. So if we use the circumference of the circle, we can find the radius. Circumference is equal to 2 pi r. So 28 equals to 2 pi r. 28 divided by 2 pi equals to r. And that gives us 4.46 centimeters, correct to 3 significant figures. Then it says calculate the volume of the cylinder. So for the volume of the cylinder, we need the height and the radius. Height is given as 20. Radius was just found to be 4.46. So volume is pi r square h. Pi times 4.46 square times 20. And that equals 1249.8 centimeter cube. The next part says that N is a point on the base of the cylinder such that BN is the diameter. Calculate the angle between AN and the base of the cylinder. So BN is the diameter. Calculate the angle between AN and the base of the cylinder. So basically, we can see that we have this right angle triangle over here. So radius was 4.46. So BN would be 4.46 times 2 because the diameter is twice the radius, which equals to 8.92 centimeters. Now for AD, we know that AD is to BC is 20. So we can find the angle using SOHCAHTOA, where we have the opposite and the adjacent. So tan inverse of 20 over 8.92 would give us the value of the angle, which is 65.96 degrees. That is the angle that AN makes with the base of the cylinder. And it says the volume of a solid cone is 310 centimeter cube. The height of the cone is twice the radius of its base. Calculate the slant height of the cone. So volume is 1 over 3 pi r square h. So 310 equals to 1/3 of pi r square h. And height is twice the radius of the base. So height is twice of the radius, so that's 2r. So if we replace height with radius, that's r squared times 2r over here. So that's going to be 310 equals to 1 over 3 pi 2r cubed now. So 310 times 3 divided by 2 pi equals to r cubed. That gives 148.01. Take the cube root of that to find the value of r, and that's going to be 5.289 centimeters. Now height is twice of that, so 2 times 5.289. That's going to give us 10.578 centimeters. So we know that in a cone, slant height is the hypotenuse. Perpendicular height is this, and radius is your base. So you can use Pythagoras to find the slant height. That's going to be 10.578 squared plus 5.289 squared. And that gives us 139.867. Square root the two sides, and that gives us 11.8 centimeters. That is your slant height of the cone. Question 20 says the diagram shows a square ABCD with side length k centimeters. MDE is a sector of circle center D. E lies on the diagonal BD of the square. M is the midpoint of M is the midpoint of AD. Find the percentage of the square that is shaded. So it's a square. That means this is K, and this is also K. AD equals to K. BC equals to K, AB equals to K, and CD also equals to K. So MED is a sector. So to find the area of the shaded region, if we find the area of this triangle BCD, that's going to be 1 over 2 times K, which is K square over 2. If M is the midpoint, this is K over 2, and this is also K over 2, because AD is K. So that means radius equals to MD, which is K over 2. Now, area of sector would be this angle divided by 360. Now, what would this angle be? We don't know that yet. But what we know is that BC equals to CD, which means it's an isosceles right angle triangle. So since this is 90 and these two lengths are same, so this would be 45 and this would be 45, which means this would also be 45. So for the area of the sector, we'll use 45 degrees over 360 times pi times K over 2 whole squared. So that's going to be 45 divided by 360, which simplifies to 1 over 8 times pi times K square over 4, which gives us pi K square over 32. Now, area of square would be K times K, which is K square. So from K square, if we subtract this triangle and this sector, that would give us this ABEM. So ABEM area would be K square minus K square over 2 minus pi k squared over 32. That is 32 k squared minus 16k squared minus pi k squared. That is 16k squared minus pi k squared over 32. That is the area of ABEM. So percentage of shaded would be this plus the triangle over the total area. So 16k squared minus pi k squared over 32 plus k squared over 2 divided by k squared, and all of this is times by 100. So that's basically 32, 16k squared minus pi k squared plus 16k squared times 1 over k squared times 100. I rewrote the divided by k squared as 1 over k squared. So now the k squares are 32k squared minus pi k squared over 32k squared times 100. So since it's a k squared everything, so the k squared gets cancelled out. So now we have 32 minus pi over 32 times 100. So that's going to give us 90.2%. That is your percentage of the shaded area. Question 8 says the diagram shows a shape made from a major sector AOB and triangles OBC and AOD. OB equals to 6, BC is 2, obtuse angle AOC is 135, and angle BCO is 90. Show that BOC is 19.5. So to show this angle is 19.5, we use SOHCAHTOA. We have the hypotenuse, we have the opposite. So sine of theta equals to 2 over 6. Theta is sine inverse of 2 divided by 6, and that equals to 19.5 degrees. Then it says calculate the area of the major sector AOB. So for the area of the major sector AOB, we need to find this angle first. If this is 19.5, angle AOB is going to be 360 minus 135 minus 19.5, and that equals 205.5 degrees. So area is 205.5 over 360 times pi times r square, which is 6. Why is 6 the radius? Because OB is the radius, OA is the radius, and OC is also the radius. They're all the same. No, OC is not the radius, sorry. OA and OB are the radius. So that's going to give us 64.6 centimeters square. That's the area of the major sector AOB. Then it says C is the midpoint of OD, calculate AD. If C is the midpoint of OD, we have to calculate this. Using Pythagoras, we can find OC. So OC square is basically 6 square minus 2 square, which is 36 minus 4. 32, we take the square root of that. OC is 5.65 centimeters. So OD would be twice of OC, which is going to be 11.3 centimeters. OA is 6 because OA and OB are the same. They're the radius. OD is 11.3. So using cosine rule, we can easily find AD because you have two lengths and the angle between them. So it's going to be x squared equals to 6 squared plus 11.3 squared minus 2 times 6 times 11.3 times cos of 135. That's going to be 259.57 square root both sides, and that gives us 16.1 centimeters. That is 80. Then it says calculate the total area of the shape. So for the total area of the shape, we can see that we have a sector and we have two triangles. If you notice in the second part, we've already found the area of the major sector. So we already have this area. All we need to do is calculate the area of the two triangles. So for the two triangles, we found OC, which for area of AOD, that's going to be 1/2 times 6 times 11.3 times sine of 135. That's going to give us 23.97 centimeters square. For the area of OBC, that's going to be 1/2 times 2 times OC, which was 5.65. So 2 times 5.65 divided by 2 is the same as 5.65 centimeters square. Area of the sector was 64.6. So total area is going to be 64.6 plus 23.97 plus 5.65, and that is going to give us 94.22 centimeters square. That's your total area of the shape. Then it says a sector of a circle has radius 8 centimeters and area 160 centimeters square. A mathematically similar sector has radius 20 centimeters. Calculate the area of the larger sector. So concept of similar shapes. Radius of one shape divided by the radius of the other shape being squared equals to the area of the first sector or the shape divided by the area of the second one. So 8/20 squared equals to 160/A2, which is the area of the larger sector. So that's 64/400 equals to 160 over area. So area would be 160 times 400 divided by 64. And that gives us 1000 centimeters square. That is area of the larger sector.